The LUM Students Mathematics Society works to bring science and mathematics to everyday coffee conversations. It is a group of talented, motivated, and well-rounded individuals who have promised to deliver this proliferation of mathematics. The LUM Students Mathematics Society aims to foster an interest in math by having events that bring out the fun side of math. For people who are already math enthusiasts, LSMS provides ample exposure and opportunities.
My happy place. Family.
Happiness.
A safe haven.
Excitement.
Community.
Motivation.
Creativity.
Hello, this is Mariam. I'm the president of the LUM Students Mathematics Society. If you made this far into the video, I assume you must really love math. And everyone should, it's beautiful. What we aim to do here at LSMS is to make as many people as possible see this beauty of math. We have some very fun and exciting events. We plan them together, we have a lot of fun together, and we look out for each other. Because that is what family is about. That is what LSMS is about. I look forward to seeing applications from all of you and see you at our orientation.
Now our president Mariam is going to talk to you guys.
Hello, Assalamualaikum everyone. I am Mariam Ali. I am the president of the LUM Students Mathematics Society. Welcome to the orientation for this year. I'm just going to tell you about our society very briefly because if I take you back 2 years, when I applied to the society, I did not know much about LSMS and I just knew that I liked mathematics. So I applied to the society. But I want you guys to know what LSMS does because it's still a society that not much people know what they do. So we have very fun events that bring out the fun side of math. We provide opportunities to math enthusiasts to celebrate the discipline, and we have talks and sessions to recognize the efforts of people that are already working in this field. We have our flagship event Sigma, which is targeted at being a very fun and competitive event, so that people from all disciplines, they can, if they have a passion for mathematics, they can come together and use this opportunity to showcase their talent. And when I applied 2 years ago, I did not know any of these. I did not know what LSMS did. But when I went in for the interview, the energy, the enthusiasm that I saw in every single person that was working in the society, that is what inspired me to be a part of this. And everybody, from every single team member to the directors to the president, everyone was so helpful and everyone wanted to help each other and they wanted to genuinely proliferate mathematics and to spread it and to make everybody see the beauty of mathematics. And that is the enthusiasm that I wanted, and it was something that really excited me as well. And I saw my ideas and anything that I suggested being implemented from day one. And that is what is going to happen this year as well. If you guys have any ideas, you guys can just bring them in. You can create a plan and execute them this year on the event. I'm sure that all of you have very amazing ideas. I'm sure all of you are very intelligent people, and you're filled with creativity. And I'm really looking forward to the value that you guys add to LSMS, and I'm looking forward to having you guys as a part of our team. And I can assure you that any ideas that you put, or any work ethic or motivation, whatever you bring to the table, it will be valued. And you will see that everyone in LSMS is very wholesome, very supportive, and we're all combined. We come together for one goal, and that is to make everybody see that math can be fun, that math can be really, really beautiful. I think that's all.
Thank you, Mariam. Next up, we have Bilal, who is our General Secretary.
Assalamu alaikum. My name is Bilal Ahmed Khan Nazi, and I am General Secretary for LSMS for the upcoming year. तो मैंने जो है फ्रेशमैन ईयर से ही काफ़ी ज़्यादा सोसाइटीज़ ज्वाइन की हैं, लेकिन जो मुझे रिस्पेक्ट, जो अपॉर्चुनिटीज़ और जो प्यार मुझे LSMS में मिला है, वो किसी और सोसाइटीज़ में मुझे नहीं मिला. और यही वजह है कि 2-2.5 साल गुजर जाने के बाद भी अभी मैं LSMS के साथ ही मुंसलिक हूँ. और अगर मैं ये कहूँ कि सोसाइटी LSMS अगर मैं ना ज्वाइन करता, तो हो सकता है कि मेरी जो भी लाइफ मैंने लम्स में अभी तक 2 साल गुजारे हैं, तो उसका एक मेजर पार्ट उसमें से मिसिंग होता अगर मैं LSMS ज्वाइन ना करता. तो अगर आप में से कोई भी आप में से ऐसी सोसाइटी ढूंढना चाह रहा है जहाँ पे आपको अपॉर्चुनिटीज़ मिल सकें, तो मैं यही सजेस्ट करूँगा कि LSMS भी वो आपके लिए बेहतरीन चॉइस है. हमने आपके लिए काफ़ी अच्छा जो है आने वाला साल प्लान कर रखा है. हमारे पास बहुत अच्छे इवेंट्स हमने प्लान किए हुए हैं. आप मार्केटिंग हमारी काफ़ी अच्छी जा रही है, स्पॉन्सर्स की हमारे पर नज़र है. आप ओरिएंटेशन के लिए भी देख लें, हमारे पास 14 स्पॉन्सर्स हैं. इसके अलावा सोशल मीडिया हमारा पिछले 1-2 साल से काफ़ी ज़्यादा एक्टिव है. और तो ये एक्टिविटीज़ सारी आप देख रहे हैं, तो हमने काफ़ी अच्छा एक साल, आने वाला जो साल है वो हमने काफ़ी अच्छा प्लान किया हुआ है. तो अगर आप की नज़र है सोसाइटीज़ पे, तो मैं आपको यही सजेस्ट करूँगा कि यही बेस्ट अपॉर्चुनिटी है कि आप इसको, जो आपके पास अपॉर्चुनिटी है, इसको यूटिलाइज करें. और मैंने काफ़ी ज़्यादा ऐसे लोगों को सुना है जो कहते हैं कि उन्हें चांस नहीं मिलता सोसाइटीज़ में, अपॉर्चुनिटी नहीं मिलती. तो अपॉर्चुनिटी हम आपको देंगे, आपने सिर्फ अपने आप को प्रूव करना है. तो स्टेज आप लोगों के लिए ओपन है, अपॉर्चुनिटी आप लोगों के लिए मौजूद है. आप लोग इसको अवेल करें और अपने आप को प्रूव करें. और इतना. थैंक यू वेरी मच.
Thank you, Bilal. Now you guys get to meet our vice presidents.
Good evening, everyone. I am Ibrahim, and as Emma mentioned, I am the Vice President Admin. And I will just say a couple of points on why you should join LSMS. I believe that we at LSMS have achieved a perfect balance in the sense that we are capable of organizing big events and impact that is equal to like the very largest societies in LUMS. Like at the same time, we don't have hundreds of people in our GB, so the people who join they will get a lot of experience, they will get leadership skills, they will get responsibility, and most importantly, they will get a room for error, a room for growth, without competing with 50 other people. Personally, I worked in marketing or registration, or उस time पे मुझे तो experience नहीं था, but LSMS has enabled me to grow and learn, and they provided me this cushion, this room for error, this room to grow. And as an EC member, I want to set the same precedent for this year as well. So do join, and without going into too much details, हमारे इस साल बहुत बड़े projects हैं, बहुत बड़े ventures हैं that are going beyond labs and beyond Lahore. So yeah, looking forward to your application and do join. Thank you.
Hello everyone, I'm Ahmed Mahmood and I'm the Vice President Events at LSMS. So first of all, thank you everyone for coming to the orientation और I hope कि आप सब हमारी सोसाइटी ज्वाइन भी करेंगे। तो सबसे पहले तो मैं ये कहना चाहूँगा कि whichever department you join, मैं I assure you कि क्योंकि हमारे बहुत सारे इवेंट्स और एक्टिविटीज़ इस साल के लिए प्लान्ड, तो यू विल हैव अ लॉट ऑफ वर्क भी और इंशाल्लाह विल बी हैविंग अ लॉट ऑफ फन। तो यस दैट्स इट। और आई होप कि आप सब लोग ज्वाइन करें अपनी जो भी पसंद की डिपार्टमेंट है उसमें, और आई लुक फॉरवर्ड टू वर्किंग विद यू ऑल। दैट्स इट, थैंक यू।
And finally, we have Mohammed Hassan, who makes up the extended council. I don't think that Hassan is here. Okay, moving on. So before we move on to our departments, you guys also get to meet our Sigma conveners.
So, Assalamu alaikum guys. I'm Walid Ahmed here, heading the event Sigma, and I've got my convener Misbah also, who's also hosting this orientation. So a little about Sigma. It's our main big event and has become our legacy around these years. The most amazing thing is the one who applies, it will actually be given a chance to head these sub-events of for Sigma. So it's generally been held in January. So yeah, you guys have a really cool winter break. So yeah, that's it. Thank you so much.
We'll now move on to our next department, logistics department.
Greetings everyone, I'm Hashir Kyani and I'm Director of Logistics alongside Hassan. Logistics is basically the backbone of our society, with our behind the scenes work in operations ensuring the success of our society's events. You will get a chance to collaborate with several LUMS departments like curricular, which will increase your confidence. You will also get first-hand experience on the procurement of materials required to meet logistical requirements by negotiating with vendors. This will increase your operations management skills. We will also help with promotions by getting pamphlets and flyers printed necessary to capture the people's attentions. The experience will be game-changing and we will ensure you will have a great time while you're at it.
Next up, we have a registrations and external promotions department.
Hello everyone, I am Ibrahim and along with Rania, we'll be the directors for the external promotions and registrations department, or REGI for short. At REGI, you will reach out to potential participants and get them to register for the various events we have planned for this year. This year, as you may know, LSMS is expanding its events, and we have new events like Pi Night, Math Circles, and an Integration Week, in addition to Sigma, our flagship event. So REGI will have a key role to ensure the participation in all these events. Good luck to everyone who plans to apply, and hopefully you will have an amazing year at LSMS. Thank you.
And thank you so much, Ibrahim. We now have marketing department next.
Hello everyone, I am Mohammed Talha. Me and Shumail are the marketing directors for this year. And in marketing department, we deal with sponsors for our events. And this is very important component of any event. If you want to learn how we do this or want to enhance your communication skills, then this department is for you. I'll encourage all of you to apply for LSMS. Shumail, if you want to say anything.
Hello, I'm audible.
Yes, you are.
Yes, you are.
Okay. Assalamu alaikum everyone. I hope you're all very fine. As Talha said, हम दोनों का marketing major नहीं है, but we are still in the marketing department. So thanks to LSMS, I guess
We have learned a lot of different things, a lot of different techniques in terms of marketing. Thank you to all the sponsors who have believed in us and who have trusted us throughout, and who are willing to sponsor for this fiscal year. We're looking forward to seeing all of you guys and meeting all of you in person, inshallah. Thank you. Thank you, everyone.
Next up, we have the Salam Sessions Department.
Hi, everyone. So what we do at Salam Sessions is like we basically host discussions and talks on physics and mathematics and how they interact and how they're related. And basically, like we try to make them interactive. And like what we in the department is that do in the department is that we organize the talks, we cover the talks after they happen, and yeah, like they're really cool. It's yeah, and yeah, like join LSMS and join the department if you like really like physics or really like math and like want to get like really nitty gritty deep into the stuff. Yeah, that's it for me.
Thank you so much, Bahaj. We now have our events department.
Hello, everyone. I'm Hashir, and I'm one of the directors of the events department alongside Daniel. We also have two assistant directors, Waleed and Ahmer. So the events department is responsible for planning and basically organizing the events that will be conducted through this year. We have currently planned 4 events to happen this year. The first one is obviously Sigma, which is the biggest math Olympiad in Pakistan. We also have the LUMS Math Circles, which are being organized alongside the LUMS Maths department. And these are for children aged between grades 6 to 12. And there are 2 intra-LUMS events that we have in the pipeline. The first one is Integration B, which is based on the MIT Integration B. And the next one is the Pi Night, which is basically a celebration of the constant pi. Also, when we are not doing events, we are doodling on Desmos, getting appreciation from Babar Azam, or making math songs. So hopefully you'll enjoy if you join this department.
Thank you, Hashir, for the amazing introduction to the events department. And now we have the media and IT department.
So my name is Hussam Kamal, and I, along with Khwaja Muzammil, we're both the directors of the media and IT department of the society. So basically, the media and IT department handles a vast range of activities, and because of that, the department is divided into 2 parts. The media section helps the society by making social media posts that are then posted on the LSMS page. So over here in this section, you will be learning skills like graphic designing and how to make interactive posts that can engage the audience. And the IT section, on the other hand, handles the website of the society. And this year, one of their projects includes the development of a new website for the society. So the amazing thing about the media and IT department is that you get to learn the skills that can be marketed even outside the society. And even if you don't have the required skill set right now, don't worry, we'll be giving you sessions whenever required that will help you to first learn and then apply the skills in a practical manner. And it's a really fun society to be in, and graphic designing is really fun. So I would encourage you to join the department. Oh, and our
Thank you so much,
directors.
Hussam. We now have our H.
So our
Hello, everyone. Yes, Hussam, you can carry.
Yes, sorry. So our assistant director are Syed Kabir Ahmed and Hassan Ali, 2 very nice people, very encouraging, and they will also be teaching you graphic designing, giving you sessions as well. That's it.
Hello everyone, I'm Noor Zaib and I'm the Director Human Resources alongside Emma. At HR, we ensure the smooth functioning of events and along with interdepartmental activities that keeps us united and closely knitted as if like a family.
Thank you so much, Noor. Now moving on to our promotions and publications department.
Hey guys, so I'm Zara, and along with Nabiha, we handle the PNP department. We are the ones who energize our social media handles and keep you guys updated with all our events. And honestly, we are looking forward to you guys being part of not only our wholesome department, but also our society.
Thank you so much, Zara. We'll now move on to our first guest speaker for the night, Dr. Fyazuddin Zaman. Dr. Zaman is a visiting professor and MPhil PhD coordinator at Abdus Salam School of Mathematical Sciences. His alma mater includes Cranfield University and University of Dundee. He has more than 120 publications and 750 citations. His work has been featured in journals such as Mathematical Methods in the Applied Sciences, Bio-Nanosciences, and Advances in Mathematical Physics. Over to you, Dr. Fyazuddin.
Thank you very much. I hope you can hear me.
Yes, I can hear you.
Yeah, and I do not know if the video is on or not. I have switched the video on. It has been a pleasure to see so many young, inspired and very motivated people who are interested in mathematics, either doing mathematics or working for mathematics. And I was going to speak about attracting more youngsters towards mathematics. I guess that was the purpose. And for that, if you allow me to share my screen, as I have the PowerPoint presentations. The host has to allow me to share the screen.
Bilal, can you allow?
Wait, let me check.
There's an option to allow the participant to share the screen. If you use that option.
You can share now.
So I'm going to just speak about why should we do mathematics and what kind of mathematics. And I hope that will motivate some of you to join your society and the Department of Mathematics, which is surely a very good research center and a center for learning mathematics for all of you. Why should we be doing mathematics? The first question we asked, what does mathematics do for us? Why does mathematics hold such an important and unique place among other subjects? That is, what is the significance overall in university curriculum, in school curriculum? And as a point of departure, in the end, I will offer a few thoughts on why mathematics should be treated as an important subject in the overall curriculum. First reason we look at what is the history of science from the very old era, the Greek period. Mathematics, that was at that time only geometry and algebra, were two of the 7 liberal arts in Greek as well as medieval times. And this historical role of mathematics supports the notion that mathematics has been favored by the educationists at that time as well, although the education was not that formal as it is today. So one reason is that the history points towards the importance of that. Then the second and the next one is the heritage, that it's part of human cultural heritage, and we have the responsibility to develop that heritage. We have seen that the science has always been benefiting from mathematics, and mathematics has always been part of the activities undertaken by the researchers, by the scientists, or by the leading pioneers in science. The next one, which is very frequently quoted, is that it is excellent for our brain. Creative and analytical skills are highly desired by employers. And this is by personal experience as well. I have been meeting sometimes people from the potential employers, even from bankers and from monetary institutions. And when they came to us that they want mathematics graduates, we asked them that, do you want anything in particular? What should be teaching in mathematics so that they can be useful for you? And they said, no, you do keep on doing what you are doing. The students from mathematics have creative mind, they can think analytically, and they can present in a logical way and in a very systematic way, and that is what we desire. We will teach them our banking or our own material by ourselves, just you teach them to be creative. So that also is a motivation and a reason that people who are not math majors, they should also be doing mathematics. And then by the same reason, it helps almost every career. Knowledge of mathematics and its complexities can help in almost every career. And if you look at even the education in medicine, the so-called medical colleges in USA, most of them desire mathematics as 1 or 2 year course done at the high school and 1 or 2 courses done during their graduation. So we usually think here that if somebody is going into medical studies, he or she does not need any mathematics, but that is not the case. Business managers, everybody knows about business mathematics now. The economists, the computer programs, the statisticians, and the social scientists, they all need mathematics. Now I come to what the mathematicians thought about the subject in the beginning, maybe 150 years ago or so. Here is a picture of a famous British mathematician who was at Cambridge University. And he is a renowned number theorist and analyst. His name is G.H. Hardy. He wrote that a mathematician, like a painter or poet, is a maker of patterns. The mathematician's patterns must be beautiful. The ideas, like the colors of the words, must fit together in a harmonious way. But soon he says, I have never done anything useful, No discovery of mind made or is likely to make directly or indirectly, for good or ill, the least difference to the amenity of the word. I have just chance of escaping a word of complete triviality that I may be judged to have created something worth creating. So he was always advocating that we as mathematicians should not care what are the applications. We should just do it because we love mathematics and it's a beautiful discipline. But about a century ago, that is what he said. But what we know today, that his work in Hardy-Weinberg principle is important in population genetics, and his work on integer partitions in number theory has been widely applied in physics, and I believe in cryptography as well. So he did not know. He believed 200 years or 150 years ago that what he is doing has nothing to do with applications. But today, there are applications. So many people ask when we talk about mathematics that what are the applications, what are you doing for the society? I always tell them that it is investment in future. We do not know today. We may not be knowing today what we are doing, what will bring in future. Like Hardy's work I quoted, that he himself was adamant that he does not want to do any application, but his work is being applied very much today. So then I will just give a few examples of mathematics and word around us, that where can we apply. We have computer science. Everybody knows computer science arose out of mathematics. And in the beginning, computer science departments in many universities in Europe were part of mathematics department. Many departments may be still named as mathematics, Department of Mathematics and Computer Science. Then comes to cryptography. It arose from number theory, which one of my friends used to say no theory. No for number, no theory, that it is useless theory. So what we do today in cryptography is based upon that theory. Then in task processing, heterogeneous multiprocessors, patterns, crystal symmetry in chemistry, and many other disciplines. There was a very long list, but I just mentioned a few. Then we have the areas in mathematics that what we want to do. One of them is differential equations, ordinary or partial differential equations, and Fourier analysis. Why they are important? Because most of the physics and engineering, electrical, mechanical engineering problems are modeled in terms of differential equations. Those of you who are just joining the university will soon discover in their physics courses, or they might have seen already in their high school, that the differential equations appearing in simple velocity, acceleration problems, etc. Then sound waves in air, linearized supersonic air flows, crystal growth, modeling of cryocooler, casting of materials, material sciences, and many others. So these are some of the applications of differential equations. Then we have differential and computational geometry, computer-aided design of mechanical parts of assemblies, molecular beam epoxy modeling, color balance, optics, cryptology. It comes again and again in my talk because many people are interested in this, airflow patterns, and so many other areas where today we can apply the model. Success in applied mathematics is a new elegant model. So the areas I have mentioned, how do we start applying mathematics? First of all, we should have a model, which should be as elegant as we can, and it should be cleverly formulated. It could be in terms of algebraic equations, as all of us are familiar with equations of algebra, quadratic equation, cubic equations, system of equations, or wherever we are studying rates of change, whether it's in price or in age or in population or any other thing like temperature which changes, we come across the differential equations model or partial differential equation model. This could involve, this our model could be involved mathematical objects like vectors, matrices. It could involve structures such as groups, spaces, and it could be in terms of tensors and so many other mathematical entities. Now, what do we do that in these problems? First, as I have indicated, task is to build a mathematical model of a phenomena that try to translate what is happening in our model in terms of equations. If it is a temperature in a plate, we would like to see how the temperature is changing, and is there a physical law which can be used to model this temperature. We know that the temperature, the heat will transfer from the hotter to the cooler part, so we can study the rate of change of temperature in terms of heat transfer, and that will give us a mathematical model. So after building this model, next important step is to establish that there exists a solution of this model. We can have a model which could be very realistic, very real, but we may not be able to solve it, or we may not be able to solve it to find out what is the solution of this model. So the next step is that we should have a mathematics to enable us to deal with this model and offer a solution, like as I gave the example of temperature. It should tell me what is the temperature at a given point and at a given time anywhere in this room. Then one is interested to know if this solution is unique. This is the next most important part. If the solution is unique, at one time I may get a solution, and at the other time I should get another answer. So a designer who is going to use this solution to design, for example, a building or an aeroplane, will not know which solution is the one which is going to occur in reality at a given time or I'm sorry, in a position. So this is very important, that the solution should be unique. I should not get more than one solution. Once I have a solution and I establish that the solution is unique, then equally important thing is the solution stable? By stability, we mean that if there is a small change in data, does the solution change also by a small amount, or there is an exponential change in the solution? Why this is important? Suppose we have the civil engineer has designed a building with a given load pattern, and there is a small change in the load and the structure cannot withstand it, and the corresponding change when the load changes a little is huge and the building will collapse. So if there is a small change in the data, in the physical conditions, in the air velocity or whatever the physical situation is, the solution should also change by correspondingly small amount. Okay, after all these requirements are met, we accept it as a mathematical model which is viable. Then comes the question that how should we find the solution, right? And that deals with the methods of solving these equations which have resulted from the model. So if I look at what I have been saying again, that in this path, we have a class of mathematicians who are modeling a physical situations into a mathematical problem. Then we have some people who are who are establishing the existence of some solutions, and they are looking at if the solution is unique. Then comes to the people working in stability theory and who work to establish that the solution is stable. And then come those people who actually give you the solutions. Sometimes people in one of these branches do not respect the people in the other branch. They think we are important because we proved that the solution exists, and the people who are actually finding the solution have not much respect for those who just prove the existence of stability but cannot find the solution itself. But I always try to stress that all are equally important. None of them can do without the other, because one contribution is useless without the other for a user at the end. And the user wants to know solution exists, it is stable, it is nice and unique, and then he knows how to find it and how to use it in his design. As I have mentioned already, not all of these questions are answered by the same researcher. These fall under different branches of applied mathematics, and the body of knowledge which is serving, which sort of provides a bank to all these people, is the pure mathematics. They have all the results which are used in answering these questions, right? So this is something which I wanted to say about why should we do mathematics and what are the different problems we can face in doing mathematics. Some of us can do one part, do the modeling. You might have heard the word mathematical modeling. Then the others can establish the uniqueness and existence of solutions. And some people can then find the solutions. So all should work as a team. And in the end, all the results will be given to the engineers. And the engineers, or if the problem is coming from social sciences, to the social scientists or economists who are going to use it for the benefit of the society at large. I think the remaining things will not be so useful for everybody, but I want to just give an example of these mathematical models. One of the problems in mathematics is about the study of propagation of waves. We know that the disturbances, the earthquakes, even the light travels by waves. Electromagnetic waves also you might have heard about. So study of waves is an important part. What I wanted to just show in this figure, that when these waves are traveling in a medium, if there is an obstruction or discontinuity in the medium, they behave differently. They diffract, some of them are reflected back, some of them pass through it, but their intensity and their amplitude is lost. And this is one of the most important things which is used in ultrasound and similar medical tests, that they let a waves in ultrasound, a wave which is have a higher frequency than the sound, pass through our body, and if there is some growth or anomaly, then the ultrasound, when received at the other end, gives a different picture, and it can even help us to reconstruct the image of the inhomogeneity. And we can then tell, is there a tumor or a broken bone or something strange in the body, without having to cut the body and see it. So this was just as an application I wanted to say. Thank you very much for being patient. I hope I haven't taken more time than I was supposed to take, but I'm so thrilled to see all the young people here who are very well motivated, and so many people who are spending time, who are giving energy and time to propagate the popularity of math, and they are also bent on serving the non-math people as well, which is very important for this subject. Thank you very much. If any comments or anything.
Thank you, Sir Fayaz, for taking the time to join our orientation, and as well as for the wonderful presentation.
So you can go on with the next item on your program. Thank you for inviting me and listening to me.
Yes, sir.
Thank you so much, sir. I think it was really important, everything that you said about the application of mathematics. Not many people know about it, and that is why they're reluctant to go into the field of pure mathematics. But I think you summed it up really well, and I'm sure everybody, it was really helpful to everybody over here. Thank you so much.
Yeah, I have even more slides there, but they would have been of interest to those people who are like on fourth semester, fifth semester in mathematics. They have done something in mathematics. So I've tried to not to use any mathematical expression. So I hope that have served its purpose. Okay, thank you. I will say goodbye to all of you, and you can continue with your meeting.
Guys, please rename yourselves as your name _ roll number, because we're starting the games right now. So basically you all will be given a set of numbers and a set of operations, and आप लोगों को वो दोनों use करके you have to come up with the number, वो भी given होगा, and you have to use brackets, और सारे numbers जो given होंगे वो आपने use करने हैं. Yeah, our time limit is 90 seconds for each question. तो my first question दिखा दो. So basically you have to use these numbers and these operations and you have to come up with the number 61. Or chat में लिख दो, whatever the operation you come up with. Guys, please put brackets wherever required. इस तरह समझ नहीं आती. Directorate can also participate. सब participate कर सकते हैं. You have a lot of vouchers.
I think Adnan Anwar answered first. He answered correctly, so I think he should get the voucher for this one.
Everybody please name yourselves as name and roll number. So it's easy for us to keep track. I think we should move on. ये क्वेश्चन दानियाल ने बनाए हैं तो उससे सब सॉल्व करवा लें जिसको भी मुश्किल लग रहे हैं. I think Ibrahim has answered.
Should we move on to the next one?
Yeah, I think we should move on. I think किसी का math questions करने का दिल नहीं कर रहा. Should we move on to another game, Ahmed?
हाँ ठीक है. Wait.
Okay, Waleed answered correctly, by the way. Achha, so basically, guys, you'll be given 4 pictures. On 4 pictures, say you have to guess a word. उस नीचे आपको एक clue भी दिया होगा तो letters जो हैं उस clue जितने मतलब word letters जितना होना चाहिए. We also have an example in the next slide. Ahmed, next slide कर दो.
Can you guys see the slide?
Yes.
इस पर स्लाइड नजर आ रही है?
हाँ नजर आ रही है.
अगली स्लाइड पे जाऊं?
हाँ. And so basically use these 4 pictures and come up with a word which has 3 letters. Chat में लिख दो. मोहम्मद तलहा, डेजर्ट में कौन सी गैस होती है? I think Waleed Ahmed and Waleed Arshad are correct. It's hot. Aina Imran answered correctly. It's right.
Yeah, Muzammil did it first.
अच्छा. Oh sorry yeah. Muzammil sorry.
दोनों को वाउचर मिलेगा.
बिलाल जिसने ये करेक्टली आंसर किया ना उसको 10 दे देना. ये कोई नहीं कर सकता.
15 करते हैं.
अच्छा, I'll give a hint. It starts from W. अब बताओ. I think Abdullah Ghani is correct. It's workshop, if I'm not wrong. आगे check कर लो. हाँ, it's workshop. Abdullah Ghani was correct. दानियाल के मैथ्स क्वेश्चंस चल रहे हैं अभी तक से.
Should we move on to the next game?
नहीं, I think it's time for a second guest speaker for the night, Dr. Ali Asher Zaidi. Dr. Zaidi is an associate professor of mathematics at LUMS. Dr. Zaidi has obtained a PhD in applied mathematics from AC University, New Zealand, where he also served as a postdoctoral fellow. In addition to this, he is also a member of the Center of Advanced Studies in Mathematics at LUMS. Over to you, Dr. Ali.
Thank you so much. Can you hear me?
Yes, I can hear you.
Okay, so can I share my screen?
Yeah, sure.
Okay, so I'm very happy to be back here again. And I really wish that we'll soon have some on-campus orientations again. But I'll talk about something about math today, which I'll try to keep as general as possible and as engaging as possible. So I'll be telling you about a way to earn $1 million today, which perhaps is the most difficult way to earn $1 million. And I'll be talking about Riemann hypothesis. So if you prove it or disprove it, in either case, you'll get $1 million, right? So I'll start with, because there's so much interest lately in Urdu literature. If you even go to the business school, there is like some Allama Iqbal poetry written there. So Mirza Ghalib has said, कह सके कौन के ये जलवा गरी किसकी है, पर्दा छोड़ा है वो उसने के उठाए ना बने. So Ghalib talks about the realm of the unknown, and that is something common with mathematics. And one of the reasons math was either discovered or invented, whatever, is that this world is made up of patterns and sequences, and there's a need of basically understanding these patterns and sequences. So we see that days become night and animals travel across Earth, and landscapes are constantly changing. Even these cute zebras have got stripes in them, which are a pattern. So there's a need to basically understand that. And the most basic concepts of mathematics, space and quantity, they are hardwired in our brains. So even in animals, if you look at them, animals do have a sense of distance, of velocity. So whether to fight or fly, or whether to be in a pack, or whether to run, or whether to be in a striking distance, all depends on quantities and velocities and numbers. So everything is basically mathematics in that sense, and understanding math is the basic difference between life and death, right? So in this context, to quantify these patterns, distances, and relationships, there was a mathematician, Descartes, and he, in his book Geometry in 1637, introduced the basic idea of mathematical relations, which we now know as functions. And here is his cute little picture. And recall, we are not going into the technical details of much mathematics, but a function is simply a rule. And we have read this definition that it takes input values, and to each input value, it assigns a unique output value. So the input values are numbers and the output values are sometimes numbers as well. So for instance, we have all seen this very naive looking innocent function f of x equals x squared, and it takes inputs as real numbers, which are on this horizontal axis, and it gives outputs which are on the vertical axis. So the vertical axis is called the imaginary axis, and the real axis is the horizontal axis, right? So this 1, 2 on the vertical, they basically are iota, which is denoted by I, and then 2 times I and 3 times I. So I is basically square root of -1, right? So one way is to say that square root of -1 is some outlawed thing, and we should ban it. But mathematicians figured out a more better way to actually treat them in a more better way. And once we have this, these two axes joined together, it gives a complex plane. So every point here on the plane represents a number. It has got two components, x comma y, which we call. So just to refresh what functions look like. So one such function is called the Riemann zeta function. And this is the notation of zeta. And it may look intimidating, but just a notation. You could use f of s if you want to. And s here is a number. And the function itself is defined as zeta of s equals 1 over 1 power s plus 1 over 2 power s plus 1 over 3 power s plus so on, it goes on. And please be careful, because it's your chance to win $1 million, and it's really better than getting free vouchers if you get $1 million, right? So if you said, let's say s equals 2 here, so zeta of 2 would be like 1 over 1 squared. So in place of s, you are just plugging in the number 2. So you get 1 over 1 squared plus 1 over 2 squared plus 1 over 3 squared plus so on, and which basically means it's a series in which we are adding up terms. So we have got 1 plus 1 over 4 plus 1 over 9 plus so on. And Euler, a mathematician, he showed that this series is actually convergent. By convergent, we mean that the sum is actually getting closer and closer to a certain number as we are like adding up the terms of the series. So there's a limit to it. So the series is adding up to a certain number, and that number is pi squared over 6 in this case, which is very surprising because pi has got everything to do with a circle and nothing to do with a series, but apparently they are linked. And why are they linked? It's surprising that this pi number is coming up in this series. So similarly, zeta of 3, I'll in place of this, as I'll start plugging in 3's here. So 1 over, this is a typo, so it should be 1 over 1 cube plus 1 over 2 cube plus 1 over 3 cube plus so on, right? It's a typo here. Again, this is a convergent series, and approximately it equals 1.20205. So we can try and plug in these numbers. But the thing is that if I plug in a negative number, let's say I calculate zeta of -1. So in place of this s here, I will plug in -1. So 1 over 1 power -1 plus 1 over 2 power -1 plus 1 over 3 power -1 plus so on. And so we know that negative reciprocals mean that we can actually write it as a sum of natural numbers, 1 plus 2 plus 3 plus so on. And it's a divergent series. You are adding up numbers, and it's not getting closer to a finite number. So we call in mathematics, we call it divergent, that it's not getting closer to a certain number if we are adding things up. And by the way, if I plug in s equals 1, again, I'll get 1 over 1 plus 1 over 2 plus 1 over 3. Again, that's a divergent series. So here is where the fun part begins. Raymond in 1859 showed that it is possible to actually plug in negative numbers in the zeta function and get limits, answers which are convergent. So zeta of -1 would or could have a value assigned to it. So rather than saying that it is a divergent series, if you are adding up positive numbers, rather than saying that it is a divergent series, actually we can assign a meaningful value to it. And in fact, for numbers which are beyond negative, for instance, if we talk about all real numbers, or in fact complex numbers, and here's some complex numbers which I have written here. So negative numbers are here, -1, -2, -3, -4, -5. These are on the horizontal axis. But if we allow numbers like -2 plus 1 iota, which is here on the plane, or 2 plus 4 iota, which means 2 units on the horizontal axis and 4 units on the vertical axis. So this is a complex number. 4 plus 2 iota is a complex number. So Raymond showed that actually we can plug in these values in the Riemann zeta function and get meaningful outputs from the function. And what's the key to doing this? So he showed that there's a tool in mathematics. We won't go into the technical details of the tool, but just to tell you the name of the tool, it's called analytic continuation. And please do not get intimidated by this horrible symbol equation which I have written at the end. The only purpose is to tell you that this function which I have written in terms of an integral, basically for values which are positive, this function gives the same values as the original Riemann zeta function, but the power of this function which we get by analytic continuation, which we say extended Riemann zeta function, is that if we plug in negative values into this one or complex numbers into this one, it also gives numbers as outputs. Those numbers could be complex numbers or real numbers, right? So please feel free to interject if anything sounds confusing. It's just I'm just introducing it in simple words to get $1 million. Maybe we can. So he showed that if you look at this picture in this plane to the right of 1, this is 1. At 1, the Riemann zeta is divergent. It does not converge because it is a series 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus so on. So it does not add up. But to the right of this 1, if you pick any number which is either real or somewhere here, and you give that as an input to the Riemann zeta function, you get a number out of it. And to the right of this one, sorry, to the left of this one, this green shaded area, you take any number, either negative or somewhere on this plane, you plug that into the zeta function, and again you get a number out of it. So 1 is the only point where actually it does not yield any finite value. And this is very surprising because now if I plug in zeta equals -1, so we have just seen that zeta equals -1 gives us the sum of natural numbers. So 1 plus 2 plus 3 plus so on. But now what I can say is that 1 plus 2 plus 3 plus so on actually equals -1 by 12. And this is astonishing that we are adding up positive numbers and we are getting the answer -1 over 12. So people call it a regularized sum, and some people call it a gold nugget, right? So something weird happens at infinity, and everything boils down to -1 over 12. Anyway, we don't want to digress to the gold nugget. We want to stick to the $1 million of the Riemann zeta function. So just to say that if you plug in these complex numbers, you get complex numbers as outputs. So the $1 million question is, for which values of s we get zeta of s equals 0? So which input values give us the answer 0, the output 0? So Raymond showed that these numbers, -2, -3, -4, if you plug in these to the Raymond zeta function, you'll get zeros. But these are the obvious ones. So he called them trivial zeros. And it can also be shown that if we take any number in this green shaded area, all the zeros, all the input values which give zero output would be in this green shaded area. We call it the critical strip. So it's between 0 and 1. But what's Raymond hypothesis is about the non-trivial zeros, which are not obvious zeros. And Raymond hypothesized that all the non-trivial zeros lie on this critical line, whose real part is s equals half. So for example, this point, half plus 5 iota, this point here, if you take that and give that as an input to the Raymond zeta function, you are going to get a 0 out. And similarly, you have got zeros here on the critical line. That's what the hypothesis is. So in case you are able to prove that all the zeros of this function are on this critical line, or you show that there exists certain point, you take any point, you could search it, people are searching it from this green shaded area, and say that for that point, the output is 0. You could still win $1 million. So it's an open question, right? So this is the Raymond hypothesis. And what's so special about finding the zeros here? So the special thing about finding the zeros here is that the location of Raymond zeta function has direct bearings on the distribution of the prime number. So if you figure out the location of these zeros on the critical line, we will be able to locate the prime numbers on the real line. Where are the prime numbers exactly located from 0 to infinity, right? So, and that is important. And that is astonishing because prime numbers live in one branch of mathematics. That is called the number theory. And Raymond zeta function lives in an entirely different branch of mathematics, which we call complex analysis. And both have a relationship. So this will give you $1 million if you either prove or disprove the Raymond hypothesis. So you just need to get 1 point, which if you plug into the function, you get the 0 output. Otherwise, you have to prove that all the zeros are on the critical line. There are, by the way, trillions of zeros that have been found yet on the critical line. Real of s equals half, and none has been found on the strip, the critical strip, apart from the zeros on the critical line. By the way, this is not the only problem that gives you $1 million. Clay Math Institute has given you 7 problems, rather 6, because this Poincare conjecture has been solved, and the mathematician who solved it, he refused to take the prize money of $1 million. So Perelman said, I do not want it. He is a Russian guy. And this shows that mathematicians actually do not work on these problems for money. They do it for their own interest. And so he solved it, and he is not doing more math these days because perhaps of some brain drain in the process. So that's pretty much I wanted to talk about. So please feel free if there are any comments. All from my side. Thank you.
Thank you so much, Dr. Ali, for taking out the time and giving us the hope to become millionaires. I'm sure किसी को तो यहाँ पे motivation मिली होगी. Thank you so much. Emma, you can share the screen. We can start with a few games.
Do you see the slides?
Huh. अच्छा, so basically, guys, you have to guess कि ये किस चीज़ की picture है. Like, what's the full picture of this thing? It's a cat. Who said it first? Aina Imran. Yes, Waleed, it's an animal. सही कहा आपने. Should we move on?
Yeah. That.
Muzammil is correct. It's latte art.
ये तो छोटी सी थी.
मुझे भी मुजम्मिल पे शक हो रहा है.
Should we play Guess the Song now?
हाँ कर दो.
Slides नजर आ रही हैं?
हाँ नजर आ रही है.
ठीक.
Muzammil, you just have to guess the song from these two emojis. किसी से नहीं guess हो रहा.
तो सिंगर का नाम बताओ.
I think we should move on. It was blank. Oh, Ibrahim is correct. It's
Oh,
blank
हो
space.
गया.
अच्छा, ये जो guess करेगा उसको गा के भी सुनाना पड़ेगा. ऐसे तो इतना easy है. हाशिर ये गा के भी सुनाओ. You invented the rule. Of, I think you should start this.
लेकिन मैंने पहले नहीं किया जवाब, तो जवाब तो इब्राहिम ने दिया.
नहीं नहीं कोई बात नहीं.
इब्राहिम की बारी है बस.
चलो let's. Muzammil is correct. वो आंसर किसने
सारे
मुजम्मिल
वाचर्स एक बंदा ही
इब्राहिम।
तो जाएगा.
Now moving on to our last guest speaker for the night, Dr. Sultan Syal. Dr. Sultan is an associate professor at LUMS and a member of the Center for Advanced Studies in Mathematics. He received the MSc Mathematics degree from Carleton University and the PhD degree in Applied Mathematics from University of Western Ontario, Canada in 1992 and 1997. Prior to joining LUMS, he has been associated with the University of Toronto, University of Western Ontario, Trent University, and Los Alamos National Lab. Over to you, Dr. Sultan.
Okay, so thank you for having me. Let me pull up my, okay, so hopefully you can see my screen. I'd like to talk for a few minutes about the joy of mathematics. So it's my contention that there's a point to doing mathematics. And what is the point? It's to exercise creativity, to see beauty, to experience joy. And Sue has come up with this, let me credit Francis Sue, to develop eudaimonia, or human flourishing. Okay, now there's an ultimate theory to this. My professor, homological algebra prof at Carleton, and during one lecture he said, when we finally solve a problem, our brains reward us with a hit of endorphins. So another theory would be that, well, we're endorphin junkies, basically. But I think that's not actually different. That's a comment about mechanisms in the brain, and all these things that I've been talking about, these also occur in the brain. So whatever the mechanism is, it's still my contention that it's these four things which are important and which lead us to want to do mathematics. Okay, so exercising creativity. Well, are we creative at all, right? Existence before anything else. Are we actually being creative? Okay, so Russell says, oh, mathematics is symbolic logic. Right? It's just symbolic logic, right? He writes an entire, I don't know how many pages before he gets to 1 + 1 = 2 using symbolic logic in his Principia. Okay, so then if it's just logic, then maybe all you need to do math are Vulcans and maybe analytic philosophers. Okay, but I would say no. Logic decides what we can call mathematically true or false or decidable. It doesn't tell us which problems to pursue. For example, it's a tool, just like an artist has a paintbrush, a chisel, right? There are tools, and they require practice and discipline to learn how to use, and they profoundly influence the resulting art, but their use is creative. The use of logic can be creative. We create, if you will, the mathematics. Now, in fact, mathematics is in fact much older than formal logic. Poincaré points this out. And he also points out that, oh yeah, we're using logic. We use logic to prove things. We discover things with intuition. So intuition is also involved, right? So again, mathematics is a creative endeavor to create new knowledge. Hardy says that, as we've seen before, Hardy says, well, we're creating patterns made out of ideas. Okay. And then what we should be creating is beautiful, right? One thing that we find beautiful is connections to the real world, right? Wigner comments on the unreasonable effectiveness of mathematics in the natural sciences. Somehow the code for the universe is mathematics. Okay. Russell says that mathematics has supreme beauty. Hardy again, there's no place for ugly mathematics. Okay. And Kovalevskaya says that mathematician has the soul of a poet. As a personal example, I would say, we were studying electromagnetism, and we had studied the Lorentz transformations, which say, if you're looking at, there's an observer, and they're seeing something, the Lorentz transformation tells you how another observer moving at a constant velocity with respect to the first observer, how what they experience. And it turns out that if the observer is seeing solely the field due to a static electrical charge, and then you apply the Lorentz transformation that here's an observer who's seeing that charge moving, you get terms that look like an electrical field. And on top of that, you get terms which are interpreted as a magnetic field. So for me, seeing the electrical field appear out of nowhere, the magnetic field appear out of nowhere when you had only seen an electric field before, as a mathematical requirement coming from the Lorentz transformations, which encode fairly simple ideas in them about how about length and distance and such things. To me, that was profoundly beautiful when I saw that. Okay. And Sue speaks of transcendent beauty. That is, again, there's a wonder or awe or delight in the beauty of the created order. Okay. Okay. And we just to give an example which has nothing to do with physics, just you see this, right? You see this, and we say it's beautiful. We know that it's beautiful. Okay. And in fact, I'm not just making this up. I'm not just saying what I feel. I can actually give you some evidence that this is true, right? Aesthetic experience in mathematicians, you can see that it activates a part of the brain called the medial orbitofrontal cortex. When people find music or art beautiful, that you see that same signature, that same activity in the same part of the brain. When a mathematician sees certain equations and not others, that same part of the brain starts working. So we experience an aesthetic beauty in mathematics that we also experience or can experience. I mean, you have to have a certain background in education. That would probably be true for art or music as well. We see this, we have this aesthetic experience of beauty. And Sue points out, so he has this, Francis Sue used to be president of the MAA, and he gave an address on eudaimonia in mathematics. Is his last speech as he stepped down as the president. That the book that's related to that speech is in the library,
And if you don't want to feel like reading a book, his speech is available on YouTube. And he compares what mathematics gives us to when people talk about the humanities and they talk about the good life, the phrase the good life, it says that it's the same thing, right? So eudaimonia, happiness, education is supposed to make you happy in a certain way. And Sue translate that as human flourishing. Okay. So one thing, it equips us to do great things. So Katherine Johnson, right? So here's a cartoon of her drawing all the equations, which are steps for getting humanity to the moon, right? It allows us to do great things, like go to the moon, for example. It also allows us to play, right? Except the playground is the mind, right? And again, it is play. I mean, it's fun, it's voluntary. There's a structure in which the imagination can be exercised. There's investigation, and it leads to sometimes to surprising outcomes, right? And as we do it, we build hopefulness and community. And, we sometimes have to keep trying to solve a problem, so it also builds perseverance. And these are all good qualities to have. And I think an excellent example of that is Conway's Game of Life, or Cellular Automata in general, right? There are often surprising results that come out of this, starting from a few very simple ideas. And ultimately, we're looking for truths, a particular type of truths, a restricted type of truth in mathematics, but we're looking for truth nonetheless, and that's the heart of the scientific enterprise. And hopefully, as we go along, we become better human beings. We cultivate regular thinking, we cultivate clarity in expressing our ideas. Okay? Above Plato's Academy, he writes, Agiometros medius esito. Let the non-geometrical man, the man who does not know geometry, leave here. Now, why does he do that? Plato's going to study politics with people. Why does he say they have to know Euclidean geometry? He says it because Euclidean geometry will have taught the student to reason. He shouldn't have to teach him basic logic. And you need basic logic before you study political science. Well, not at Carleton or other universities, but okay. All right. So, and hopefully it also leads to humility, right? There's an endless supply of mathematicians who are better than I am. I accept that. I hope, though, that I can do something that's of some use to somebody. Okay. So, these, I think, are just, in 10 minutes, I think the things that can make mathematics a joyful experience for us. Thank you.
Thank you so much, Dr. Sultan, for taking out the time. Does anyone have any questions? Ibrahim, games khatam ho gayi.
I don't have questions, but I just wanted to say thank you, sir. It was really amazing, the talk you gave. Thank you so much for giving the time and effort.
Sure, thanks for having me.
Yes, sir, thank you.
नहीं दानियाल हमें और नहीं चाहिए ऑपरेशंस के सवाल. So if no one has any questions, so we can conclude the orientation. So thank you everyone for taking out the time to attend our orientation. It was an absolute pleasure to host you guys and hope to look forward to your applications and have a great year ahead together. Also, best of luck for the interviews for those who are applying. I'm sure everybody.
अस्सलाम वालेकुम। पहले मैं ये स्ट्रीमिंग बंद कर